He's not.
Yeah, well, we're going to move on without Colin, and we'll go ahead and read his bio anyway, just so it's on the video, but we'll see. So, everyone, welcome to the 1:30 panel on microbe life. I am Shango, host of the Shaping Fire podcast. If you love hearing excellent information from cannabis experts, I encourage you to check out shapingfire.com. That's where my podcast lives. Jeff Lowenfels has been on the show, so there's that fantastic show to hear. Also, we've got a blossoming YouTube channel now that's serving over 500,000 minutes of exclusive cannabis content that I've recorded at conventions. So you might want to check that out. So, on our micro panel today is Jeff Lowenfels. He is a reformed lawyer and author of the award-winning and best-selling books Teaming with Microbes, The Organic Gardener's Guide to the Soil Food Web, Teaming with Nutrients, The Organic Gardener's Guide to Optimizing Plant Nutrition, and his third book in the Soil Trilogy, Teaming with Fungi, The Organic Grower's Guide to Mycorrhiza. Jeff also writes the longest-running gardening column in North America, having never missed a week in 40 years.
44.
44, that's right. I wrote this a while ago. And while you're clapping, in 2005, he was inducted into the Garden Writers Hall of Fame, the highest honor a garden writer can attain. So that's pretty cool. Also with him is John Piccirilli. He is founder of Cutting Edge Solutions. As an early adopter of the soil food web system, his business is rooted in sustainable agriculture. John helped develop the cutting-edge product line to support natural soil ecology, including their flagship product, Hum Tea, and co-founded a microbiology lab in 2004 to support their research efforts. One of John's current side projects I love is growing milkweed and a variety of pollen-producing flowers for migrating monarch butterflies. So let's assume that Colin's going to join us, and we'll plug him too. Colin Bell is the co-founder, co-inventor, and chief growth officer at Growsentia, the parent company of Mammoth Microbes, which is probably where you've heard of him before. Colin completed his PhD in soil microbial ecology in 2009 as a researcher and scientist at Colorado State University. Colin published dozens of peer-reviewed publications that were focused on microbial-mediated processes that enhance plant growth. Colin left his academic position in March of 2015 to launch Growsentia. Their first product, Mammoth P, is a beneficial bacterial bloom stimulant that targets phosphorus. So, the way that we're going to do the panel today is we're going to present the panel a question, and then each panelist will have a chance to take a swing at it. Unfortunately, the panel is only 45 minutes, so we're gonna be moving along pretty swiftly, and we may or may not have time for questions at the end. So, Jeff, let's go ahead and start with you since you're closest. So Jeff, in a commercial growing operation, conservation of resources, including time and money, is vital. And changing from traditional cannabis growing techniques consisting of bottled salt nutrients to instead using holistic growing techniques that bring the soil alive can seem differently expensive in time, training, and changes. Management often resists making the switch to living soil because they're afraid of the risk involved with doing something that they say differently, that is different. Can focusing on building thriving microbe communities in commercial operations be financially beneficial in addition to just being natural?
Yes. And I say that because I think we're about to see the biggest change our industry's seen in a long time. I think we're going to be seeing beer companies and tobacco companies, the big pharma companies come in and grow stuff. And we know that they're going to grow stuff the way they make cigarettes and the way they make beer and the way they do everything else they do. It will not be a natural system. And the way that you're going to be able to distinguish yourself from them, I believe, is because you're going to be organic and natural and clean. Those early articles in California that 1 out of 5 grower plants didn't make it, the testing, et cetera, you're gonna be the positive side of that story. And so I think definitely it is going to be worth it from an economic perspective, regardless of whether you believe in it or not.
What are your thoughts, John?
Well, that's a good point in that, sustainability means you can save soil. And so by reusing soil, that's one of the key factors in labor and, wasting time, wasting money. As far as salt-based fertilizers go, that means pretty much everything in a bottle, because if you think about it, seaweed is a salt-based fertilizer. Salt-based means that it's on the SI or salt index, and the salt index is made out of sodium nitrate, and sodium nitrate actually is an organic fertilizer. So it gets kind of confusing when you say salt-based, but there's a lot of people that are going back to amendments and going back to compost teas, and that's a good thing.
And I think that Jeff's point that by differentiating yourself as somebody who's growing with living soil and probiotically, I mean, it's a huge marketing win for you. It's a product differentiator that you're not going to find just anywhere. And also, I know what Colin would have said to this question as well. Colin would have also said that it is a misnomer that using living soils and building healthy microbe communities is less yielding, right? Historically, people think that, oh, you have to use bottled nutrients in order to get these monster yields. But what we're finding is that as we relearn how to take care of our soil, yields are increasing and are being as competitive as with these traditional products. So John, this next question is for you. So much of the market for flower is based on bag appeal, and many consider frosty flowers and intense coloration to be the result of intense synthetic nutrients. What can commercial scale growers do to create frosty flowers with great bag appeal while also respecting the health of substrate microbe communities?
I caught like half of that question because I was watching Colin run it. But
The quick
and he had a big
summary
smile
of
on
it.
his face. But I think I can just work off what I think that question is. And when you say bag appeal, of course, everyone is looking for frosty flowers and the terpene levels being boosted. And as a fertilizer manufacturer, I mean, probably the most important thing is manganese. Manganese is a key micronutrient that all plants need, and they'll take it, turn into an enzyme that acts as a catalyst and moves nitrogen through the plant. But in the Cannabiceae family, where there's hops and cannabis and pot, basically cannabis, the manganese is even more an important role as the basis for the terpenes being made with the early building blocks. So how do you get more manganese in there when manganese is only available in soil at like a pH of 4? And the way to do that is microbial breakdown. And we actually have a product that we use microbes to break that down. So microbes play a key role in being able to build a terpene profile. And mammoth pea has some good bacteria in it that also make phosphorus more available. And you don't want to overload your soil with too much phosphorus, too much bone meal, or even too much using products that have phosphoric acid in them, because they'll shut down mycorrhizal fungi relationships. And that's another benefit of using microbes that make, like Bacillus megaterium or Pseudomonas putida, that will make more of the phosphorus available. And phosphorus, of course, adds to the flower structure. But then there's a whole different school of thought out there now. Something that there's already a question.
Well, let's hold questions to the end in case we have time. Thanks.
As far as getting the flowers more frosty, there's a lot of different fungi and bacteria that produce amino acids. And we have an amino acid product that kind of mimics that, and it's organic, and that boosts the actual structure of the glands and swells them up, and they get more crystals on them. So as far as building a good flower structure, you're dealing with a lot of microbes. As far as building good overall look and terpenes, once again, you're looking at microbes processing elements such as manganese. But then foliar spraying, a lot of people do that with hum tea or compost teas, and they find that actually influences the plant and gives it more flavor and more crystal structure. And I built a lab, and I've worked for over 20 years in trying to figure that out, but that's not like a 1-minute question. So Colin could probably explain it.
Colin, welcome. So the question that we asked when you're running in is, can using microbe communities and living soil create flowers that have got the bag appeal and are sexy and will compete with the kind of stuff we see from synthetics and petroleum products?
Yeah, I think, there's interactions with all that. And so it's not just one thing. There's no one solution, and there's a lot of solutions that we have to bring together to achieve our final goal. And the final goal is quality, and we think these quality metrics is bag appeal is one. it's not really my personal metric for success. It's the quality of the terpenes and maybe the chemical constituents and that smell or that flavor that translates from the smell. I want that terpene flavor or the terpene smell to translate to that flavor. And then there's even a more sophisticated interaction where sure there's THC and CBD and other cannabinoids, but then we know that there's these interactions with all of these terpenes which helps enhance the effect, how this flower makes us feel. I've tested and looked at a lot of different strains where the CBD and THC is the same, but they have completely different effects. And there's all this chemical interactions which contribute to that. And so how do we make that full package? It's by what John said, maximizing the plant's ability to take up the resources it needs to maximize its full phenotypic potential. And I think to a large degree that we have to make sure the nutrients are there, and then we have to make sure the nutrients are bioavailable and that they can be taken up. And so that's an interaction with maximizing our plant genetics and our environment. And then what we're talking about is the inputs and the availability of these inputs. And availability to a large degree is a microbial function, maximizing the plant's ability to open up. And I got out of breath running, sorry.
You're doing
I
good.
ran from way across the way.
Quick, pass it to Jeff.
And so just to maximize your plant's ability to develop through the nutrient uptake, and that's the microbes, just like John was saying.
Yeah, I mean, the microbes are what take the organic materials and convert them into an available substrate that the plant can take up. And I think it's important for everybody to understand the plant uses 17 nutrients. You can't put a terpene down in the soil and expect that terpene to go into the plant and come up out and be a crystal. That's not how it works. Each plant cell produces what it needs. Those trichomes are producing the terpenes and then making the crystal and putting it outside. So it's happening inside the plant. What you have to do is give the plant, as both these gentlemen have said, everything they possibly need in order to make that little factory operate properly. You can't have a boycott with China over the tariff for phosphorus because you're not going to end up with the right kind of beans. You've got to make sure that you've got everything in the soil that you need. It's just that simple. And the other thing two other things I think you have to worry about. You have to worry about genetics. Or I guess you'd say three things. Genetics, you have to worry, because if you don't have great genetics, you're not going to get, great terpenes. It's the genetics of the plant, which I think you said when you said phenotype. You've got to have great sunlight. You got to have great light. If you don't have the very best possible light, then the factory's not operating at its optimum, thing. And then I guess the other thing you have to have is gentleness, because that's, they're in these little crystals, and too many people who are doing hydroponic come in and shake the plants and do this and that. You got to be careful and gentle. And then the last thing I'll say is I think we got to do a lot more research, not on a microbial level, but on a cellular level and on an insect UV light level, because it's pretty clear that UV light is one of the things that causes these trichomes to grow. So let's figure out what spectrum, where it is. Can we alter it? Can we change it? Is there a special time to have one kind of UV light over another? All that kind of stuff. I think that's as important as the microbial stuff. So anyway, that's it.
Right. So Colin, this next one is for you to go first. So establishing a commercial operation can seem like a long-term project, and it is. But at some point, cultivators who want to make the switch to probiotic growing techniques have to make the jump and get up to high yields and repeatable results fast. What advice would you give to a professional cultivator ready to make the switch to living soils so they quickly achieve a baseline of production that they can refine over time?
So we're going to refer this right to living soils instead of just solutions. What I think, I'm just going to kind of talk about how I'd respond to that question. Jump from a hydroponic grower, let's just have the full extreme, a hydroponic, full hydro grower to a living soil grower, that's a heck of a jump. And I don't think that's a quick path. I think they're stair-stepping. So understanding the steps of moving that direction and having this end goal of this is what we want to look like, and these are the kind of things that we need to start adopting and practicing in our grow and getting those results and stair-stepping over to that full organic living soil cultivation is what we're going to do. I think that this has been a really fun week, and kind of reflecting on the last 2 weeks, I was and a bunch of huge grows in California and like the Salinas area, really, really high throughput, acre-sized greenhouses, full bore. And then the last week I spent with a bunch of growers and farms up in Humboldt, where it's a lot smaller scale, living soil, the hugel growing and all this type of stuff. So it's very fascinating to take all that information and kind of synthesize it and understand how does, you know, the Humboldt hugel living soil type of grow get scaled into a high throughput manufacturing or cultivation facility. And I think that I don't think speed or is realistic. I think consistency and having clear benchmarks and a clear goal of how to get there is the answer. And I think part of that is understanding the different components that get us there. You know, there's this substrate component, there's this input-based nutrient component, and then there's these microbial and living soil components. And we might not get all the way there, but I think I would encourage facilities that are huge in our commercial scale and are looking at really high throughput. I've talked to them as they're getting from point A of where they are right now, cocoa and synthetics, to organics and microbials and other inputs in living soils. They're going to find the solutions that work best for their current practices that they can plug in and then take the next step. I think one of the big steps, and I'll leave it up to the other guys, is substrate. One of the facilities that I visited, big facility, had the synthetic cocoa, the normal stuff, and then their biggest challenge was organic substrate to grow in. And you wouldn't think this, they're adding the microbes, they're doing the things right, but what they're getting challenged with, and this, you know, it's really intuitive if you just kind of acknowledge it, is the drainage. You know, if you start to get this organic living soil in a pot or in a container, it compacts and does something, and the hydrology is very different than a cocoa. And that was one of their biggest challenges. So understanding how to scale every aspect of those inputs to get to this end goal of whatever kind of scale of living soil they can achieve with their infrastructure is the goal. And I don't think that greenhouse is going to grow like the growers in Humboldt, but I think that they can achieve to the best of their ability natural inputs to get organic, higher quality end product using natural solutions. And a lot of those are probably commercial. You know, at the farm in Humboldt, the growers are trying to get all their inputs from their land. You know, that's not going to happen at these commercial facilities, so finding the other sources for those inputs is key.
Oh, next, so you said hugel, so that means they're cutting down trees and putting them into
Yeah, have you heard of this
dirt
before?
berm. Yeah, I've seen this. I've built these things before.
Yeah, there you go.
And it's kind of interesting, you know, because it depends on the tree you select. I mean, you could select cedar, bad choice. Does not break down. Black locust, forget black locust, you know, that does not break down either. But fir breaks down pretty well, and some people actually grow in redwood sawdust, and like the substrates that you're talking about, there's a lot of different companies that use redwood sawdust as their base, and they kind of do that for a number of reasons, but one of them is because if cocoa coir all comes from one or two sources and it's all treated with calcium nitrate, so you can never get an organic certification on cocoa coir unless, you know, you deal with a specific company. Like Royal Gold, I think, has an organic cocoa coir, but I mean, they're a large company, but in the scheme of things, they're very small, and they're also in Humboldt. But that hugel stuff is kind of interesting. I don't know if anyone here has seen this. You've seen this before?
Who's seen this? Raise your hand if you know that.
Oh
You
wow,
know,
that's
yeah.
way
Okay.
more people than I
Yeah.
thought.
If anybody wants to see these drawn out, I actually visited the same farm that Colin went to at Moontime Medicinals, and it's got pictures of their 6,500 square feet of Horticulture in Garberville, and you can see it on the Shaping Fire YouTube channel. It's incredible.
Yep.
But back to you, John. So the question we were working on was making the switch from synthetics to probiotics. And what would you recommend for somebody wanting to move in that direction, trying to take their company in that direction?
Oh, because they're straight. Well, you know, you have to look at it as being indoor, greenhouse, or outdoor. You know, you're not going to do a hugel structure indoors. You know, some people might try it. I mean, you know, I've seen investors buy anything. You know, because it's just say cannabis enough times, and you know they're throwing money down. Wow, hugel, even that sounds great. You know, and organic. Oh, I gotta have this. But you know, in a greenhouse, it's more challenging because you know you have to have the height, of course, and then you have to have the airflow too, and they tend to trap a lot. These mounds tend to trap a lot of humidity. But outdoors, you know, you are actually seeing it being used outdoors more. To take the steps, you know, it's kind of interesting because this whole industry is changing so fast. I mean, I was talking to this chemical engineer and a PhD chemist that used to work for Novartis, and they're in Willits, and they clean oil for $2 to $3 a gram. And you know, these are the first people that I've actually seen. You know, I'm not going to talk about their process because I said I wouldn't, but they can do it, and they can end up with a clean product. And that, you know, that's a big issue because in Salinas they're worried about all the drift. I don't know about you, but when I go down there, I get a headache after 2 days because you know they spray so much.
It's a real challenge with the surrounding agriculture in particular. Yeah.
It really is. So you know, you almost have to have wet walls to trap a lot of the vapors coming through, and then of course that builds humidity. And you know, your question though was, how do you step from some pure rock wool hydroponic setup to ultimately having living soil? And like Colin said, and you know, if you read Jeff's books, you realize that you know, that's not easy. That's like either a complete commitment, and you pretty much have to own the property at that point because the overhead will kill you. But it's certainly worth it to make those different steps. And microbiology is with you every one of those steps. You know, it's in liquid form. You have mammoth pea. You have, you know, Jeff talks a lot about compost teas. I mean, these are the things that are going to help your plant along and sustain your plant as you test out these different substrates and ultimately, you know, try to work with an amended soil. And you know, you're going to end up foliar spraying quite a bit to keep the plant going. So, you know, I guess I could probably lay out the answer by describing a couple of different places, but I don't know how much time we have to just, I mean, I go on and on.
Well, you know, we're still doing pretty well on time, so you
Okay.
know, you're an interesting dude, so just, you know, let it ride.
Well, you know, so you were in Humboldt, and Humboldt is, you know, has always been a place of a lot of experimentation. I have a ranch there in Willow Creek, and you know, I'm right in there with all the experimenters. And so I started experimenting in 1978 when I was a kid, and grew my first cannabis crop. So I've been doing this for a minute. You know, this I guess makes 40 years. And so I've seen a lot of growers succeed, fail, or just go on to do other things. And the microbiology was always there. And in Humboldt and Mendocino, you know, they had the advantage of being in there early, and then of course attracting all the helicopters, which pushed their cultivation back into the edges of the woods where all the microbiology was. I mean, things coming off lichen, and you know, other plants interacting, and you know, that's kind of where I got my education was, you know, as a kid, digging holes, you know, using a flour sifter to add the amendments, and because I didn't want to get, you know, hit over the head with the shovel for doing the wrong thing. And you know, gradually I got really good at it, and so I got to work at a lot of different places. And I realized I had to go back to school to study microbiology because there was more going on than just fertilizers. And you know, that led me to actually looking at other plants and other plant compounds. And you know, there are products out there now that are, you know, almost like homeopathic products of just small amounts of certain other plants. I mean, you know, we have a whole biostimulant line available commercially that's plants from Southeast Asia and North America and a couple plants from Africa, and they're harvested at different times, and they have different, you know, compounds in them that influence the plant in making roots, growing, blooming, and then of course boosting terpenes. And that comes from John Jevons and Chadwick, who, you know, brought double digging to this country from France. And you're giving the thumbs down on Chadwick?
Bad, double digging, very bad.
Uh-oh. Let's go to Jeff now about double digging. I haven't heard this myself. What do you
It
think?
destroys the mycorrhizal network. It's bad for the soil food web. Double digging once, and then after that, you've done it. Yeah, it's an outmoded concept in my mind.
Yeah.
Particularly when you know the microbiology. You don't
Right,
need to double dig.
right.
Okay, I'll be-
No, I actually learned that from, my girlfriend forced me to farm with draft horses for several years. And, I would do anything, right? And so,
Wouldn't want to be in his bedroom tonight. Horse. Oh, sorry.
yeah, right. I was whipped into this, trust me, working with draft horses. But that's where I learned about the degradation of the ozone layer and the fact that fungi was being destroyed by flipping the soil too deep. Because, in like 1990, I was growing quinoa, and I thought, ripping the soil with a D7 cat was a great idea. Well, I'm learning from old farmers, right? So I thought, that this is how you do it out here in, Lassen County. But then I started to look at more soil samples, and I realized under my scope, I'm like, wow, there's less fungi than if I just go to the outside of the field where it's undisturbed. And then I realized I had to do more fertilizer inputs, and I was like, wow, this is going to cost me money deeply ripping. And then I looked around and I realized why they were all going out of business and why I could have an organic farm there, because they couldn't afford their own fertilizer inputs.
So it just proved that in fact you can go commercial from organic,
Synthetic,
from
yeah.
non-synthetic. So you did it.
Right, in a roundabout way.
Yeah, I would do it in a slightly different way. I mean, given where we are today, I'm just looking out at the audience, so I would start with something like Keto Life, or I'd use BioNatural. I'd get a system that's in place, that's got 4 or 5 or 6 different inputs, right? How many do you have? You got 5? How many do you have?
Well, I have up to 16.
Up to 16
depending on
inputs.
what you want.
And both of these can be used, and I don't mean to pick on these guys, but there are other people out here, organic as well as inorganic. So you can use them in a hydro system and a soil system. So you're starting to make that conversion. You can understand what's going on, what's working, what's not working, and then you work on the substrate, which is what you've mentioned, and you convert it into a soil substrate. It can be done, and it's not that difficult. If you got enough money, you hire a consultant. They do this all the time. But you start with a base, somebody's system that you know works, and that's got some scientific background that you can read on and be able to tweak and think about. And then you say, okay, now I've got this system and it's working. Now, let's fool around a little bit with Mammoth P. Let's see if it makes a difference. And you add that into the system. And after a while, frankly, and I think you guys will all agree, you don't really even need to add the stuff in anymore once you get your system working and it's alive and you've made the conversion. So yeah, it does work, it can be done, and it's easy to do for individual, small people. Less easy for bigger people, but if you use a system that's based on, known, works either hydro, which I consider to be synthetic, obviously, and works soil, great, then you can start really tweaking that stuff. And that's what you gotta really do if you wanna make that conversion in any kind of economic, speedy way. As far as the inputs are concerned, while you're making that conversion, you start looking around for where there are good inputs and who's not using what waste product that you can use that they're not using. Where's there a grow where somebody's inadvertently or stupidly throwing away their soil after every grow? Maybe you want to go get that stuff. You know what I mean? I mean, there's ways to do all this stuff, and it's just out there, and everybody wants to help you because everybody wants a little bit of your organic cannabis to keep going. So that's where I come from.
So actually, that sets us up for this next question. Great. So this time we'll go Colin, John, and then we'll finish up with you, Jeff. So this applies for both home growers and patients, and also for commercial folks, because as we all know, you need to be choosy about which products you purchase, because some of these products can be expensive. What would you recommend as being a few inputs that can be grown either simply at home or larger at a commercial scale, that can be grown and add high quality inputs to a probiotic soil in order to help keep costs down? Go ahead, Colin.
That's it. I wish we wouldn't have started with me. I probably need to reflect on this question for a second.
You ready, John?
But it comes down to, I'm good.
Are you?
Yeah, I'm prepared now.
Did you catch your breath? I know you really came in running hard, so.
So I really did. I was like, So what it comes down to me is chemistry. and biochemistry. You know, at the end of the day, I think about everything as a chemical profile. A lot of the papers I did in science, I have a background, I'm a research scientist from Colorado State University, a PhD in microbiology, and that's what I was doing for a long time. And I was really fascinated not only with plant microbe interactions, with nutrient stoichiometry. That is, we all have a C to N to P to K ratio in our bodies. So do plants, so do microbes. And these are the things that we're trying to fulfill. We eat food because we're trying to fulfill our internal stoichiometry, our nutrient demands, our nutrient needs. That's what we're trying to do with a fertility program. We're trying to deliver the nutrients that the plants need so they can grow uninhibited. And so thinking about these inputs, what you want to think about them is at a biochemical level, the nutrient profile level, and you grow those things up. You know, for example, alfalfa is a really good example as a legume where it actually incorporates more nitrogen into its biomass because of the way it fixes that nitrogen. And so forage alfalfa is a really good example of a relatively higher nitrogen input. You want to think about these aspects, and you can actually test forage or test other, you know, any kind of input for its nutrient profile, and that's why you're selecting these. And so I think thinking about that, thinking about the scale that you're growing, and all these things go into effect. But generally what I would say is if you don't know what's in it, you can't use it with precision. Any microbe, the function, any of these inputs, you have to identify that. Once we understand what it is, we can use it with confidence and precision and consistency.
John?
That's good. You know, you're going back to the Humboldt example. I mean, experiment, right? Experiment in your own gardens, on your own farm, but keep a control. You know, a lot of times people just broadcast completely, and then of course, you know, then they say, oh well, it didn't work that well on this control, but the control was just the weakest plants. Don't select the weakest plants for your control. You know, you mentioned a number of things, like for instance, if you're in a forested area, here's something you can do. Get organic milk in small containers. Bury it, open it up, bury it up to the level of the milk so it stays cool in the soil, and see if that turns to yogurt. Often that is good lactobacillus that you're getting right out of the soil. And you can take that and you can actually put that into a tea. If you want to test different milks, that's always a great one. You know, you can get commercial milks, and when you actually get it close to your nose, you know why that's not really a food.
What's your favorite milk?
Well, since I'm in Sonoma County, it's Strauss. Strauss organic milk. It comes in glass bottles, and the neck is just perfect, the perfect size for bringing in microbes. It's like an old school, microbiology flask, you know. So that's a good one, and you know, it just shows people that there's something already in the soil. So many people want to just wipe everything out, you know. And this is the sort of thing that Jeff was saying before about double digging. You know, double digging now has evolved, so you're breaking up the lower soil, but you're not taking the soil and completely flipping it. When it started out, they were flipping the soil completely, and they were wiping out all the fungi. And you know the example I gave was, you know, ripping the soil, and then of course you're flipping it up. And once you go deeper than 10 inches and expose it to full sun, you basically wiped out the fungi, and you've got to do something to replace that. And you know, just going back to the idea of teas, I don't know if anybody uses, you know, how many people in here make tea, compost teas? Wow, that's a lot of people. That's good. How many people here have heard of Elaine Ingman? That's even better, you know, because I was at the... We can't promote him that much. He's already standing. But it's good. It's good that you've heard of Elaine Ingman, because you know she was one of the pioneers in sort of bringing the whole tea culture thing back. And you know, a lot of people took it pretty far. You know, they started to use wheatgrass, and you know, wheatgrass has zeaxanthin in it, and corn, seed corn, and you know, you get different enzymes when you make a fermentation out of that, and then put that in the tea too. So there's a lot of things to experiment and try. I don't know, I'm drifting really far from the question. But
We can bring it right back. So Jeff, since you haven't hit this one yet, and maybe you could actually name a couple species of plants that people can grow. So we're talking about inputs that people can grow, either at home that they can put into their plants that will be helpful and save them some money, or be done at a commercial level where that maybe they'll do, a handful of rows. And so what are those plants?
Well, you can get any number of cover crops, obviously, lentils, there's all sorts of red clover, white clovers, and their whole catalog is just full of cover crops, and all of them will work fine. One of the things I think that really you need to do though is, as you say, you need to know whether the stuff you're using works, and that means testing. So you've got to test. People don't test. You got to test for NPK. You got to test for the microbiology using a Lane Ingham's test. I think you got to test using this new microbiometer so you know what kind of biomass. And you've got to use these tests intelligently. You got to. Some of them are expensive, some of them are cheap. You've got to be able to meld them together so that it works for you. And you've got to be able to retest to see where you're trending. And too many of us don't. You get a fine looking crop, you go, hey, I must be doing everything right. You don't know unless you test. Information's power, we've always been told that, we believe that, and yet, as growers, we don't test enough. We've got to test. And I think once you test, then you start putting in inputs because you want to test to see whether it's working. When you buy a product, you test to see whether it's working. If it doesn't work, you don't buy it again, et cetera, and you get that. But it does start with growing your own inputs if you can. You can grow your own mycorrhizal fungi. You can collect your own mycorrhizal fungi from natural areas around your property or around your existing grow. Your existing plants contain all sorts of things that you want to use. Again, I always talk about you don't throw away male plants. You use the whole root system for both males and females because that's put unbelievable exudates into the soil. You want to collect that kind of stuff. If you see somebody that's throwing away their male plants, go collect that stuff. I mean, you have to be intelligent about it. And of course, we all are. That's why we're here at this thing. Everybody else is out, in the sunshine getting cancer. So, yeah.
that was cruel.
To add to that, I think, overall, we think about this minimalist approach of having a living soil because we want to reduce our input and keep what we have and continue to use it. But we have to understand in that particular substrate, plants are always taking away from that substrate.
Law of return.
It's allocating resources that it's gaining, mostly all nutrients from the soil, into its biomass, and you're harvesting that, so it's going away. So there's never a complete regenerative in agriculture that there's not some type of replenishment. And so there's certain resources. I don't know how many growers are out there using things like soil testing, nutrient analysis, where from one crop to the next where your nutrients or substrates may be deplete. So you can just add those specific elements in with precision and not add everything. Your soil might not need everything. It might need some very few items, or and there's an example where even phosphorus, there's total phosphorus that might be in your substrate but not available, so add a catalyst to maximize the availability of that phosphorus. And you don't need to add any phosphorus in any cases. A lot of micronutrients are clear examples. Nitrogen is always a horrible problem, and maybe you need a source every year.
Well, if you use Mammoth P, you don't have to use phosphorus, and in fact, you can't even buy phosphorus in lawn food anymore.
That's one of the challenges with some nutrients because it's been so abused in agriculture and other places. They're banning phosphorus in general fertilizers unless you can prove that your soils need it significantly, so you can actually justify that purchase. And so, it is a movement of using biologicals. It's not just us that are up here preaching this. All agriculture segments are trying to understand and adopt biology because it's a necessity for our environment, for the ecology, and for maximizing crop quality and yield, quite frankly.
And sexing and CBD and THC.
Yeah, lots of applications, that's right.
Hey, one thing that keeps getting mentioned though is foliar spraying, and there was an article that came out in Science Magazine last week, I think, about foliar spraying compost tea, I think it was, and what it did to the fertilizer situation in the plant that had also been foliar sprayed, and what it did to the exudate mix in the soil. So foliar spraying is apparent to me something we need to study a lot more than we have been. We study the roots, we're not studying the foliar quite the same way, and I think we're going to get there. But you got to be careful when you foliar spray.
Why?
because this article says that when you do that above ground, you are impacting what happens below ground. And just Google foliar spray, fertilizer below ground under news for this week or last week, and you'll get the article. And
Or
it's
go
pretty
to
interesting.
or go to KeyLifeGarden.com and check out my article on foliar.
KeyLife.com, article on foliar applications.
Right on. So,
It's a good
so in
resource.
finishing up, I know this is crazy because we've got all this experience, but they only gave us 45 minutes. So we are complete here. So the three fellows will be here for questions afterwards, but for the moment, we need to start shifting for the next speaker. So thank you very much to John.
Well, we burnt it up, no questions.
Good work.